Okay, in this video we're going to take a look at spin. Spin's a great little dynamics operator. We're going to go ahead and create a couple rules. In this first rule, we're going to plant a black box that we had created previously in the test 2 category called draw simple. This just creates some particles, gives them size and an initial direction down the world y-axis. Nothing too exciting there, but we're going to go ahead and modify their size, make the largest one that, and maybe a 90% variation. And in this second rule that we've got, we're going to go ahead and create a rule that's going to affect the all group. And what we're going to do is grab an operator, dynamics, and use a spin. We're going to put spin over here. Let's just go ahead and see what happens by default. We can see that those particles kind of rotate around random axis fairly slow. That is because our spin time is set to 10 seconds, which is kind of a long time to do a revolution. And the spin axis control is set to random. Let's go ahead and use a direction of travel. So now this is interesting. The direction of travel is actually a vector in world space. So it's going to calculate which direction they're going and apply that to the particle. So these particles are now spinning around their y-axis. If we go ahead and set this to user defined, it's going to spin around this world axis, which is the z-axis. So now they'll kind of spin that way. And one of the important things that we're going to take a look at in just a second is the axis input for spin. This will gives us great control over controlling how they spin. We'll take a look at that in just a sec. What we want to do is take the spin time and set that to 2. And we'll add some spin variation so they don't all spin the same rate. Let's actually have them spin in random axis. And we can see there that some are spinning faster than others. And let's go ahead and whip that around. Okay, but the important thing that we want to look at is the dependence. And these two dependence factors allow us to amplify the spin value based on either speed or size. If we place more emphasis on speed, like an emphasis of 10, then particles who are moving faster are going to get more spin than particles who are moving slow. That's a bit fast, so let's do that. Let's remove that variation so that we can really see exactly what's happening. And still, boy, they're trucking. Let's go ahead and set that to 10. Okay, a little bit better. But we can see these big guys who are moving faster are spinning faster than these guys who are moving slow. Let's actually come back to that draw simple black box, and we're going to add more speed variation. We'll add 90% variation. So now we can really see that effect. Okay, so just remember the dependence on speed. When we set this really high, it's going to affect these faster particles more than the slower particles. And let's go ahead then and also take a look at the size. Let's put an emphasis of 10 on the size value. Nah, not a whole lot's happening there, so we're going to go ahead and change some of these values. We'll set spin time to 2 and the size to 2, size dependence to 2. And what we see is that when we use size dependence, larger particles spin slower than smaller particles. But that the smaller particles, as we increase the size dependence, that small particle is also going to actually spin a little bit slower. We can counteract that effect by decreasing the spin time, and that's going to actually tell them, hey, I really want you to spin really fast, but also take into account this size dependence. So now you can see that there really well. Okay, that's all great, but what we want to look at is using the user-defined spin axis control. And what this user-defined does is it lets us either use this vector here in world space, or we can go ahead and feed in something into this axis. And that's what we want to do. We want to actually use the direction that the particle's heading and spin either forward or backspin based on that axis, direction of travel. So what we're going to do, we're going to come back to the velocity that we had set at birth. Remember, this only affects those born particles. And we're going to add some direction variation to them. And we'll scrub out here. Let's actually give a little more variation. And let's take a look. Now we've got some particles. These guys are, they're actually going up to So they kind of go off in those directions. This one's going off in this direction. What we want to do is calculate a spin axis that takes a look at the actual direction the particle's heading and is going to calculate either backspin or forward spin. The way we're going to do that is some pretty simple math. It's nothing to be afraid of. We're going to go into the M3D vectors, grab a VOPS. This is actually just an expression helper. It's an expression helper that's got two vector inputs and a vector output. And what we can do is we'll just change this from a plus to an x, which is going to mean cross product. So vector 1 cross product with vector 2. It's going to output a new vector for us. And what we want to use is we want to use that particle, each particle's own velocity. And we're going to go ahead and multiply that with a 0.3 helper. So we can define our own axis. We're going to use 1 in the z. Take that vector in there, and then go ahead and take that whole output that's calculated. And remember, this is calculated per particle. Each particle has his own velocity setting that gets fed in here. And so what happens then, this cross product gets calculated, sent out, and that will be used as the axis. Remember, the cross product is kind of the 90-degree angle of two vector calculations. Okay, so now what we get is, let's take a look at these particles, the way they move. We can see that these guys moving up are kind of spinning around an axis that would be going in this direction, while this small little guy, his axis of rotation is kind of more like this. And you can see this is backspin. If we go ahead and take this 0.3 and set this to -1, what we'll get is forward spin. And if we want to change whether it's add some variation to this forward spin or backspin, what we can do is use a random helper back here, per particle animation. We'll take that value into the z. We're going to set z now. We're going to set that to 0 with added. So any value that comes into this 0.3 z value is only going to be added with 0. And we'll take a look at more about all these helpers later. And so now we're going to generate a random value between -1 and 1. Let's switch that seed around. And now some of them, you can see that all these four guys are all doing forward spin, while this one guy here is the only one who's generated a negative value, so he's doing a backspin. We can't see really the we can't see it too well with too few particles. We'll go ahead and just remove that particle draw and throw in a position born. Make this connection here. And actually what we'll do is take our variation angle to 180. And we'll go ahead and throw this out here. We got to change their lifespan. Let's make it 300. We're going to change our particles per second to not be too crazy. And we can see that as these particles come shooting out, they're given an initial velocity with some direction variation. So they're going to be going out in a full circle at this point. Go ahead and increase that speed and decrease the variation. And you can see that the direction that each one of them is going, we're calculating this this backspin with a cross product. So each one is going to be spinning around direction to travel. And you can tell, you can see like this guy right here, he's going in this direction, and the axis he's rotating around is directly perpendicular to that. Okay, so enough about spin. Spin's a great way to add extra motion to particles, especially during fragmenting. And we'll take a look at how we do that in another video here soon.